Welcome! Today we are going to talk about quadratic equations and problem solving. These are really the fun problems from this section. Okay, so you've actually learned enough now that we can start to solve some interesting questions. These are some guidelines here that will help us go through each problem by following these steps. So pause the video and write these down, and I'm just going to walk you through them one by one. First, of course, you read the problem until you understand what it is you're trying to find and what it is the problem is saying. So you may have to read the problem 2 or 3 times for it to make sense, but reread it until it does make sense. Then depending on the problem, if it's possible to draw a picture, we'll want to draw a diagram. That's step 2. And after that, we may need to introduce some variables, you know, your x's, y's, t's, whatever, unless they're specified in the problem, and then we may not need to. But sometimes you'll have to come up with your own. Okay, and then what you'll do is you'll translate the question from words into algebra. We'll practice doing that on the following examples. Then sometimes you'll need to solve equations, and then in the end you'll interpret your answer so that it actually means something. Alright, so make sure you pause the video and write those down. I'm going to move on here. Let's do an example. So an object is dropped from the roof of a 144-foot tall building. Neglecting air resistance, the height h in feet of the object above the ground after t seconds is given by this quadratic equation. H equals negative 16t squared plus 144. So let's find how long it takes for the object to hit the ground. So the first step was to read until you understand. So, okay, an object is dropped. It starts at the top of a 144-foot tall building. It falls, and then it hits the ground after some amount of time. Okay, and what we're trying to find is how long does it take to hit the ground? That's what we want. Okay, and looking at the variables here, t represents the seconds after it's dropped. So what we really want here is we want a t value because that will tell us how long, right? Because t represents the number of seconds since it's been dropped. And h represents the height of the object after t seconds. Okay? Next we'll draw a diagram. So here's the ground. Here's a building. Okay? And it is a 144-foot tall building. Okay, and we've got a little person up here, and they drop the object from the side of the building and it falls down. Okay, so there's our diagram. Now, introduce variables if they're not specified in the problem is step 3. Now, we're given that h represents height of the object in feet above the ground after 10 seconds. So if the object is here, let's put these variables on the diagram. Even though they're already given to us, that might help us to understand. So if h is height above the ground, let's say the object is here, that means this distance is h. So it's not how far it's fallen, it's how far it has until it reaches the ground. So let's think about this. What is the height of the object when it hits the ground? Right? When it hits the ground, what is the height of the object above the ground? Well, if it's on the ground, the height above the ground would be 0. So when it hits the ground, h would be equal to 0. Okay, that's part of interpreting, and let's see if there's anything else here. If h is 0, let's see, we can use that to solve the equation for t, because if we replace this h here by 0, we'll have, because this is true when it hits the ground, h is 0, so we'll have 0 equals negative 16t squared plus 144. Well, that's an equation with only one variable that we can solve. So let's solve this equation. Now we're on step 5. There wasn't a whole lot of translating to be done here. So we're on step 5. Let's solve. Let's see. Is 144 divisible by 16? So let's check on the calculator. 144 divided by 16 is 9. So that does factor out. So we can factor out a negative 16, and we're left with t squared minus 9. So that actually factors further. We just did one just like that. That factors into, because it's a difference of 2 squares, t squared minus 3 squared. So it factors into t plus 3 times t minus 3. And now it's fully factored and it's equal to 0. So we can use the zero product principle and set each factor equal to 0. Now before you do that, what you can do is divide both sides by negative 16 to get that out of the way. 0 over 16 is 0. So we have 0 equals t plus 3 times t minus 3. And so we get, setting each factor equal to 0, we have t plus 3 equals 0, which gives us t equals negative 3. And we have t minus 3 equals 0, which gives us t equals positive 3. So we have two solutions. Now we have to ask, does it make sense to have two answers here? This would be interpreting our answers. And no, it definitely does not make sense to have two different times at which the object hits the ground. And a negative time certainly doesn't make sense. Sometimes that will happen. Okay, this one does not make sense. So our real answer is t equals 3. Okay, and let's interpret that. It says find how long it takes for the object to hit the ground. So let's say therefore, 3 little dots are shorthand for therefore. It takes the object 3 seconds, S is for seconds, to hit the ground. Alright, so there is your first applied quadratic problem. Let's work another one. The square of a number minus twice the number is 63. Find the number. Now there's really two ways to do this. One is a guess and check method, and that's not what we're learning about here. The goal isn't really in this section, the goal isn't really to solve the problem. The goal is to solve the problem using quadratic methods. Okay, so because we want to solve this using quadratic methods, we're not going to just guess and check. And if you do that, you're not going to get any credit on your test, okay? The idea is to learn how to set up a problem using algebra. Because when you get into the higher maths, it's impossible to guess and check many of the solutions to the problems you'll be doing in things like calculus. So you've got to learn how to set up equations, because otherwise the problems get too complex and they're impossible to solve. So the point, remember, is not to get the answer, it's to learn how to set up equations that will get you the answer. So let's go back to the steps. The first step said to read it until you understand it and draw a diagram, introduce variables. So those were the first 3 steps. Now this is a pretty simple problem to understand. The square of a number, so a number squared, minus twice that number is 63. Find the number. Okay, and then it said draw a diagram. Well, you really can't draw a diagram of a number minus a number, so there's nothing to draw. So we're going to go straight to step 3, which was introduce variables. There are no variables given here, so we're going to have to introduce our own. So let's go with x. Always start with saying let x equal or let x be. That's how you define x. You actually have to write it out in a sentence. Okay, you can't just start throwing around variables if you don't explain what they are first. So let's, in this case, let's let x be the number, because that's what we want to find. There's our variable, meaning this number here. Now let's see, step 4 said translate it from words into algebra. Now this one we definitely have some translating to do here. Okay, the square of a number. That means the number squared, so x squared, minus twice the number, that's 2 times the number, or 2x, translates to equals 63. So I literally just translated this sentence word for word into an algebraic equation. And now this is something that we can solve, which is good. It's a quadratic, and so we do have to get it equal to 0 first. Remember, do not do this. This would be wrong to factor out an x over here, because now it's factored on one side, but it's equal to 63 on the other, and you cannot set each factor equal to 63. That only works if you're setting it equal to 0. So instead, let's move the 63 over to the other side first so that it's equal to 0, and now factor. 63 breaks down into 7 and 9, which will give us a 2, as long as we put the minus with the 9 and the positive with the 7. And then we set each factor equal to 0 and solve. So we get 9 and negative 7. Now it doesn't say that the number necessarily has to be positive here, does it? It just says the square of the number minus twice the number is 63. And it appears like either of these will do that. If you're not sure, we can check. So first let's check x equals 9. 9 squared minus 2 times 9 would be 81 minus 18. Now let's check. 81 minus 18 is 63. So that one does work. Now let's check x equals negative 7. Negative 7 squared, okay, that is not negative 7 squared. This is negative 7 squared. You do have to have parentheses around the negative 7 because if you don't, this says square the 7 first because of order of operations and then multiply by the negative. So that one would be negative 49, not positive 49. Minus twice the number, so minus 2 times negative 7. Let's see, negative 7 squared is 49. And this would be positive 14. Adding those together, we do get 63 again. So both of these are solutions. And since it doesn't say that the number has to be positive or negative, they're actually both answers. So there we would say, therefore, the number is either 9 or negative 7. All right, let's do another problem. So try this one on your own first. Make sure you try all the problems on your own first, but pause the video and then watch it and do it with me. Okay, so the length of a rectangle is 5 feet more than its width. The area of the rectangle is 176 square feet. Find the length and the width. Okay, so we're finding length and width of a rectangle. Pretty simple. This one at least we can draw a diagram of, so let's draw a rectangle. Okay, area is 176, so I'm just going to put that in the middle here. The length of the rectangle is 5 feet more than its width. So it's longer than it is wide, and it's 5 feet more longer than it is wide. So how do we say that? Well, we need some variables before we can state that. So we need to introduce a new variable. What I would do is probably call the width W, because then the length would be 5 more than that, or W plus 5. So we're going to let W equal the width. Remember to define your variable. And if W is the width, then the length is 5 more than the width. So then the length here, this distance, would be W plus 5. You could also call it X or any other variable. The letter you use does not matter. All right, now we need to translate it. Well, there's really nothing left to translate. We've put the width, we've put the length, we've put the area, but we do have to set up an equation here. And of course, what's the equation, right, that you know that relates width, length, and area? Well, the area of a rectangle is equal to the width times the length. The width here is W. The length here is W plus 5, and the area is 176. So now we have an equation that we can solve for W. It's a quadratic equation because if you multiply this W out, you'll get W squared plus 5W. And it's not equal to 0 yet, so let's make it equal to 0. And, ooh, that looks like a tough one to factor, but hopefully it will. All right, we need to find how does 179 break down. So I'm just going to factor it by its prime factors here. This is just scratch work. Okay, 176, if we divide that by 2, we get 88. If we divide that by 2, we get 44. If we divide that by 2, we get 22. Divided by 2 is 11. Okay, so this is the prime factorization of 176, which means there's lots of ways to break 176 down. But we want the middle term to be pretty small, so I want to choose two numbers that are close together. So I'm going to first try grouping the 11 with the 2, and then I'll also try grouping those three numbers together. 2 times 2 times 2 is 8. So I'm going to break 176 down into 8 and 22. If we do that, 8 and 22 Do not in any way add to 5. Now, except that one of them has to be negative and one has to be positive, because they do have to multiply 2 and negative. And the bigger of the two numbers has to be positive. But positive 22 minus 8 is not 5, so that's not going to work. So instead, maybe let's try grouping. I'll just switch colors here. Let's try, well, let's write this again. Okay, I'm just going to switch colors to differentiate. We need these two numbers, 8 and 22, to be closer together. So let's try grouping all of the 2's together and then just having the 11 there. So let's try that. 2 times 2 times 2 times 2, that's 2 to the 4th, is 16. So I'm breaking 176 down into 16 and 11. And now that works because 11 minus 16 is negative 5. So we should be able to write these in a way that will get us 5 for the middle term. So let's make the bigger number with the positive so that we end up with positive 5, and the smaller number 11 with the negative there. Okay, so we've got it factored. Yay! Now we set each factor equal to 0, and from here it's easy. W equals negative 16. Or if W minus 11 equals 0, then W equals 11. You can jump straight from here to here if you don't want to write out that step that says W minus 11 equals 0, which if it's more complicated looking, I recommend you write this step here, setting it equal to 0. But for one this easy, you can just jump straight to that. Now we have to ask, what is the real answer to the question? Okay, it says find the length and the width of the rectangle. Well, for one, we haven't even found the length yet, so we're not done. And for 2, we got 2 widths, except a negative width does not make sense. So we're just going to cross that one out. So the width must be 11, in which case the length, I'm going to call it cursive L there, length would be 5 more than 11, so the length would be 16. Okay, now this would be a perfectly fine way to write your answer, except that I left out units. We'd have to add feet and feet. Or you could come write a sentence and say, therefore, the length and width should be 16 feet and 11 feet. Okay, so there's that problem. And let's go do another one. Make sure you try it first though. Find 2 consecutive odd integers whose product is 23 more than their sum. So 2 consecutive meaning in order. So 2 consecutive integers would be 3 and 4 or 10 and 11. But 2 consecutive odd integers would be like 9 and 11 or 13 and 15. Okay, so they're next to each other, but they're both odd. Whose product is 23 more than their sum. That's interesting. Okay, so we don't have any variables given, so we will have to come up with those. We can't really draw a diagram on this one either, and the problem itself is fairly simple to understand. So we're going to jump straight to, I believe it was step 3, introducing our own variables. Okay. So we're finding 2 integers. Now that doesn't necessarily mean that we necessarily need 2 variables. So let's just introduce 1 variable and see if we can figure out how to make the problem work with only 1. Because the fewer variables you use, the simpler the problem will be. If you introduce 10 variables when you only need 1 variable, you're making the problem way harder than it needs to be. So try to keep it to a minimum number of variables. So let's let x be one of the numbers. Actually, more specifically, let's let x be the smaller of the 2 numbers. And then that way, let's see, the next odd integer after that would be x plus 2. So then x plus 2 would be the other number. So we did not have to use 2 variables here, only 1, because both numbers are in terms of x. Okay, so for these 2 consecutive odd integers, their product is 23, so when we multiply them together, we get 23, so x times x plus 2 is 23. And, oh, no, that's not right, whose product is 23 more than their sum. So here's their product, that is 23 more than their sum. So let's see, their sum, maybe I should rewrite this out here. x times x plus 2, let's write it in words first, is 23 more than their sum. Now their sum would be x plus 2. Okay, so x times x plus 2. Let's simplify and then we'll kind of rewrite this as an equation. So I'm halfway done translating but not quite there yet. Okay, x times x plus 2, let's just leave it like that, is, translate to equals, 23 more than this would be 23 plus this quantity here, x plus, now these parentheses here aren't really serving any purpose, so I'm just going to drop them, x plus 2. And we have an equation that we can solve for x. Let's see, if we expand this x out, we'll get x squared plus 2x, so this is a quadratic. And on this side we'll have x plus x is 2x, and 23 plus 2 is 25. Okay, it's a quadratic, so we do need to get everything on one side and set it equal to 0. Now if you look at this, if you subtract 2x from both sides, look what happens. It cancels on both sides, so that one goes away. And then I'm going to subtract 25 from both sides, move it over to the left, to get it equal to 0. And so this is you should recognize how to solve this. It's a difference of two squares. This is 25 squared minus 5 squared. So it will factor into x plus 5 times x minus 5 is equal to 0. And then we set each factor equal to 0. And we get x equals -5 or x equals 5. Now because we got two answers, I'm going to actually check both. Okay, so let's come back up here. So this is where you would want to draw an arrow so I could follow your work. Let's come back up here to check. Okay, let's check x equals -5 first. If x is -5, then the next integer would be -3. That would be the next odd integer. So we'd have -5 and -3 would be the two numbers. Their product would be -5 times -5, -3 is 15. And their sum, -5 plus -3 is -8. Is 15 25 more than -8? Well, let's see, 15 minus -8 is 15 plus 8, which is 23. So that one does work. And I suspect the other one will work as well. So I'm going to check x equals 5. If x is 5, then the two numbers would be 5 and 7. So 5 times 7 is 35. And their sum would be 5 plus 7 is 12. Is 23 more than 12? And the answer is yes, it is. So therefore both of these are solutions. Now that we should still answer the question. Okay, the answer is not x equals -5 and x equals 5 because the problem doesn't say anything about x. So if your boss said find two consecutive odd integers and you told them x is -5 or 5, they're going to probably look at you and say, well, that doesn't make sense. What's x? And those aren't even consecutive odd integers. So so let's go answer the question then. I know I have to scroll down so you can't see the problem. But therefore the two integers are either -5 and -3 or 5 and 7. Now that answer makes sense. It's a meaningful answer. Okay. And we're going to do one more example here, so make sure you try it on your own first. Alright, the length of one leg of a right triangle is 7 meters less than the length of the other leg, and the length of the hypotenuse is 13. Find the lengths of the legs of the triangle. Okay, so lots of information here. So you have the length of a leg is 7 meters less than the length of the other leg, and we're given the length of the hypotenuse is 13. We want to find the length of the legs. It's a right triangle too. So when you draw it, one of the angles is going to be 90 degrees. The legs are probably not the same. No, they're definitely not the same. So here's our 90-degree angle. So the hypotenuse is 13. That's opposite the right angle, so there's 13. And it says find the lengths of the legs. Well, these two sides are the legs that we want to find the lengths of. The length of one leg is 7 meters less than the length of the other leg. So one of them is 7 meters less. So we need to introduce some variables here so that we can write that. So let's just introduce, I'm going to just use x, but you can use any variable. So let's let x be, let's go with the shorter of the two. So let's let x be the shorter leg length. So on my picture, this one looks shorter, so I'm going to put x there. Now it says one leg is 7 meters less than the other leg. So if the shorter leg is 7, then the other leg is x, then the other leg is 7 more than that, or x plus 7. Okay, so we have our picture, we have variables, and we don't have anything left to translate. We've translated the whole problem, so we have to set up an equation using what we know. This is kind of like this one we did before with the rectangle and the area. You had to know to use the equation area equals width times length to set up the equation in order to solve. That's a pretty basic equation that you can be expected to know. This one right here is. Okay, and if you're not given an equation in the problem and you have nothing left to translate, again, that means we've got to set up our own equation. So what equation do you know about a right triangle that relates the lengths of the legs and the hypotenuse? Okay, if you've forgotten, that's completely okay. That's why I'm doing this example. But the answer is there's something called the Pythagorean theorem. The Pythagorean theorem. And what it says is that the length of the first leg squared plus the length of the second leg squared is equal to the length of the hypotenuse squared. Okay, it's a very interesting relationship. I'm not going to go into where it comes from. That's for a geometry course. But what it says for us is that this length squared, which is x, so x squared, plus the other leg length squared, which is x plus 7, all squared, so make sure you have parentheses around the x plus 7, because the whole thing is squared, is equal to the hypotenuse squared, or 13 squared. So that's the equation that we can use to solve. So we have an equation with x's. Let's solve this equation. Looks like a quadratic because the highest power of x I see here is 2. And if we FOIL this, let's write it out first. Okay, x plus 7 all squared. Remember that means x plus 7 times itself, so times x plus 7, and then you'll have to FOIL it, is equal to 13 squared. 13 squared is 169. Okay, so make sure you don't do this. X plus 7 all squared is not x squared plus 7 squared. Okay, that is not correct. You do have to write the whole thing twice because everything is squared, and then FOIL. So let's FOIL this out here. For the first terms, we get x times x, or x squared. The outside terms are positive 7x, and so are the inside terms. And the last term, 7 times 7 is 49. Okay, and let's see if we can simplify. X squared plus x squared is 2x squared. Then we have, so that this comes from that and that. Then we have 7x plus 7x, that's 14x. And plus 49 equals 169. So we have combined like terms, but it's not equal to 0. It's a quadratic equation, which means we have to make it equal to 0 before we can solve. So we need to move that 169 over. Okay, so what is 49 minus 169? Do that on your calculator. 49 minus 169 is negative 120. So minus 120 is equal to 0. Now it's equal to 0, so hopefully this thing factors. Before we factor, it looks like I can take a 2 out of everything because these numbers are pretty big. So let's do that. Let's take a 2 out. Makes the numbers a little bit smaller at least. And then you don't even have to show the next step where if you divide both sides by 2, you don't have to write this, but I'm going to do it to make sure you get it. The 2's go away. So then we have x squared plus 7x minus 60 equals 0. Hopefully that factors. Let's see, 60 factors into lots of different things. The one thing it factors into that will add to 7 that I can think of is 12 and 5. 60 does break down into 12 and 5. And one of them's got to be negative, one's got to be positive. We want them to add to positive, so we'll put the positive with the 12. And if you FOIL that out, you will get back x squared plus 7x minus 60. So then we set each factor equal to 0. So again, you can actually write it like this. Or you can just say, well, if x minus 5 equals 0, the answer is going to be x equals 5. Okay, so we get negative 12 and 5. Now let's see, does that make sense? A triangle cannot have a leg that's negative length, so that one does not make sense. So x must be 5. Now the question says find the lengths of the legs. So this means one of the legs, or the shorter leg, has length 5, and then the other leg is 7 more than that. So therefore the lengths of the legs they are 5, always include your units. Here we're in meters, so m, and 7 meters. Okay, so that's it for the examples that we're going to do in this section. Some of the homework problems in this section will be pretty challenging to set up on your own. If you get stuck, just ask, that's okay. And so good luck working those problems, but give them your best try before you do ask. And tune in next time. Next we're going to move on to chapter 7, so we're going to move on to a new topic.